Good morning. It's Saturday morning, and I just graded, in finger quotes, all the homework. A couple of things. First off, I did not count anyone down for being late. I gave you until midnight. We're gonna have to, both of us are gonna have to watch the deadline times on these things. I generally want things turned in during the day because that's school time, and that's when I work. But this worked out just fine. So, a couple of comments. First of all, people did a pretty darn good job. Second of all, I noticed I suspect there's a number of people working together, which is perfectly acceptable. But the reason I suspect it is here in number four. The choices are F, G, H, and J, and a whole slew of people put E down as the answer. I want you to notice that they have A, B, C, D, and then they skip E and they go F, G, H, J. This was a trick that the state standardized test used a few years ago. To keep people from putting the wrong answer down, but it certainly didn't stop you guys. I suspect it's because the choice F is actually elastic potential energy, and that's the correct answer for number four. Okay, some other ones that I wanted to highlight that I think people had a little trouble with. Number 17. What did I say? Number 17. Calculate the frequency and period of the light. We had a lot of people with just crazy answers, and it's not such a hard problem, so I'll show you how to do that one. And a lot of people skipped number 19, and I understand that the video on the standing waves came out a little late, but list three wavelengths that could form standing waves on a 2 meter string that's fixed at both ends. And people just listed types of waves: transverse, longitudinal, electromagnetic. That's not what it says. It lists three wavelengths, so we'll have to talk about how to do that one. Number 20 was the one that was most often missed. People got an answer that was about double the size. So we'll figure out exactly how that works. And number 21, a lot of people struggled a little bit with that one. I'm not sure we really want to go over number 21 because there's plenty of people you can talk to that did it right. But let's talk about 20 and 19 right now. So we'll do them in that order: 20 and then 19. Get the old piece of paper, the old recycled crossword puzzle here. So number 20 is the one about the lighthouse, and you have to kind of read it carefully to understand what's going on. So there's some sort of lighthouse here, and I'm going to draw a building, and then on top of the building is kind of a area where they keep the light, and it's got a roof on it. So that's my idea of a lighthouse. And inside the lighthouse, somebody's going to suspend a pendulum all the way to the bottom. And that's the idea. There's a spiral staircase inside that goes around this thing, but they've suspended the pendulum all the way from the light all the way down to the base. So the height of the lighthouse is the same as the length of the pendulum. Okay, that's the whole idea here. Um, and they give you the period of the pendulum, which is 9.49 seconds. Okay, now the way to solve this problem is to get the period formula. Period is 2 pi times the square root of, now let's see, the longer the pendulum, the longer the period, so L goes on top, L over G. And we're looking for L, so we have to do some algebra on this. The first piece of algebra that I'd like to do is to divide T by 2 pi, and that leaves the square rooty thing by itself on that side. And that would mean that the next piece of algebra that would be good would be to square both sides. So we have T squared, we have 4 pi squared, and that's going to equal L over G. And we've almost got L alone by itself. We can just move G to the other side, taking it from the bottom to the top, and that means that L is going to be G times T squared over 4 times pi squared. Put the numbers in, and you got 9.8 for G. T squared is 9.49, and we have to square that, and 4 and then pi squared, whatever that is, it's on the calculator. So let me get my calculator out, and we'll, oops, it's all tangled up over here with my census information. Okay, here we go. 9.8 times 9.49 squared divided by 4 and divided by pi, where's that pi button? Pi squared equals 22.35 or 22.4. So this is going to wind up being 22.4 meters. And like I said, that's an answer that's about half of what you guys got. So I don't know where you went wrong. Um, Probably somewhere in here you zigged when you should have zagged. It's probably an algebraic mistake, but a few people didn't understand that the length of the pendulum is the same as the height of the deal there. Okay, now number 19. That was number 20. Number 19, we want to talk about this list three wavelengths that could fit in an area that rope has a fixed end 2 meters apart, if I'm reading that right. So this is going to be 2.0 meters from here to here. And so let's draw three copies of this thing here. So the simplest wave that fits in there is a wave that has only one antinode. That's one hump. The second simplest is one that has two humps, an up hump and a down hump. And the third one is an up hump, a down hump, then an up hump again. And so this would wind up being a wavelength that's equal to twice the length. In other words, that's only half a wavelength in there. And so that's going to be 4 meters. This one's going to have a wavelength that's exactly equal to the length, so that's going to be 2 meters. And this one's going to have a wavelength where 3 lambda over 2 equals L. That means that lambda equals 2/3 of an L, which is 4/3, which is, oh boy, 1.33 meters. So those are the three easiest things to answer on that one. As far as number 17 goes, let's see if we can squinch out a little area over here to talk about number 17. 17 says the green light has a wavelength of 5.2 times 10 to the minus 7 meters, and the speed in air is 3 times 10 to the 8. Ooh, my pen is going crazy. Meters per second. There we go. And they want to know what the frequency and the period of the light. Well, the frequency is pretty easy because we take the wave equation and we just monkey it around so that we get that frequency equals V over lambda. So we're going to go ahead and take 3 times 10 to the 8, 3 exponent 8, and divide it by 5.2 exponent minus 7, and we get 5.8 times 10 to the 14. Can I make this fit? And that's going to be in hertz. Now, if you want to use the wave equation in its other incarnation to find the period, then that means the period is going to be lambda over V. Hey, look, frequency and period are inverses of each other. Oh, yeah, huh? So then we can just take an inverse, this answer, and then we'll hit the inverse button, and we get 1.7 times 10 to the minus 15. Now, what is the period? Period is in seconds. So those are the answers for that one. All right, hope you enjoyed the homework. We're going to move on and start talking about sound here pretty soon, and enjoy your day.